So, terminology for matrices. A matrix is an array of numbers or symbols, but we're typically going to be dealing with numbers, arranged in rows and columns. So, rows are horizontal. You can see here row 1, row 2, row 3. Columns are vertical. So, that's important to know. Here, so some terminology that you must know. The order of a matrix is going to be really important, especially when we get to multiplying, which we might start at the end of class today, or we'll do it at the beginning Monday. An order of a matrix is the number of rows by the number of columns. Rows always come first, columns are second. Whenever I was in school, our teachers would tell us to think of RC Cola, which really wasn't a big drink back then, but they did still have it. Do they still have RC Cola anywhere now? I think it's like a throwback vintage thing. You might be able to get a few places, but it's not widely available. But RC Cola for rows, then columns. So matrix A below has an order of, so you would have your number of rows. So you've got 1, 2, 3 rows. And then you got 1, 2, 3, 4 columns. So this would be a 3 by 4 matrix. Sometimes, I've pretty much got it now, especially since I've taught it a couple times now. Matrices are on the ACT, but they are not in high school curriculum until you get to pre-cal or Math 4 in North Carolina. They used to be in our curriculum, but they took them out. If you get a little bit stuck, your calculator can help you a little bit here. If you forget about the order, there is a button on your calculator, or not a button, but if you hit the blue button and then matrix, you have a matrix menu. If you go over to edit, it's going to ask you for the order of the matrix before you put it in. So like if I do a 2 by 3 matrix, I can see, oh, there's 2 rows, there's 3 columns. Whereas if you got it backwards, if you do 3 by 2, it won't be what you're expecting. So there, we are going to use the calculator some, but probably not today. But that can help you. All right, so give the order of each matrix shown below. So I'll let you do that. Rows, then columns. Okay. Summer, what would the order for number 1 be? It's 2 by 3. Noelle, what about number 2? 2 by 2. Grace, what about number 3? 4 by 1. And Caitlin, what about number 4? 4 by 3. Okay, so pretty straightforward. Everybody has that. Not really complicated, but important to know. The elements of a matrix are typically given, so like if we ask you for an element A2, 3, that means second row, third column. So like if we want to, if we have a 3 by 3 matrix here, then this would be 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. Right? First number is your row, second number is your column. Same here. So if I have this right here, element A, 2, 3, 2, 3 would be second row, third column. So right here, 1 would be that element. So that's just some notation that you'll see. Okay, so for this matrix that you have right here, find all of those elements. So like just a quick example, A2, 1 would be the second row. So you got like 1, 2, 3, 4 here, and then you got column 1, 2, 3, 4, 5 up here. So if you're looking for 2, 1, second row, first column, that would be right here. So you get -2. So find all of those elements for me. Okay. Braden, what do I get for number 2? Yes. Let's see, Braun, what about number 3? -6. Good. Caitlin, what about number 4? Good. Blaine, what about number 5? Wonderful. And Jackson, what about number 6? -4. Very good. All right, so again, just a little practice, a little terminology. Nothing major here. So adding and subtracting matrices, super duper easy. You're just going to add and subtract. In order for you to add or, first of all, in order to add or subtract matrices, they must have the same order. So this would be the same size matrix. So you cannot add a 2 by 2 and a 3 by 2. The reason is to add or subtract, you just add or subtract the corresponding elements. So like if I'm doing this problem, to get this first spot, I just do 4 plus 1. So I would get 5 in that first spot. And I would do 8 plus 0, which would give me 8 right here in that second spot. 3 plus 5 would also give me an 8 right here. And then 7 plus 2 would give me a 9 right here. So they have to have the same order because otherwise you don't have anything to add to it in that section. Is that blank on yours? It's not, is it? It's not blank over here on the little. What's happened to my picture? What's it look like? This has some you're adding, right? Go ahead and add those together. I don't have them up here. Apparently that picture gave out on me. Let me open it here. what I've got. Double check me to make sure I haven't made some mental math errors. See if you guys got the same. Do not assume necessarily that I am correct. I may have made a mistake on these. You guys see anywhere that mine is different than yours? To me, what's most difficult is when you have to do, when you're subtracting. So you've got like -1 minus -2. So -1 minus -2 is really like -1 plus 2, which gives you 1 right there. So be careful. One thing that you can do for this, if the negatives are tripping you up, you can take that and make it a plus sign as long as you change the signs of everything in the matrix. So then you just have to have, 4 plus -4 is 0, -1, +2 gives me 1. So you don't have to worry about that. You could do that like right here as well. Just have to change the sign of everything in the matrix if you do that. So that might be a strategy you want to use if those negatives are tripping you up. Okay? All right. Why are all the pictures not showing up? Okay, I'm going to close this and open it back up and see if anything magical is going to happen when I do that. Okay, there we go. All right, so now it's working. Scalar multiplication is when we're just multiplying a matrix by a single number. So if we do scalar multiplication, we just multiply every number in the matrix by that number. So it's basically like just distributing that 2 to all of those numbers there. So if we have something like number 1 right here, if we're multiplying by 6, then we're just multiplying all those numbers by 6. So we'll get -18, 42, 24, we'll get 12, 48, 36, 6, -30, -54. So it's just the exercise in multiplication tables. We've got 2/3 times this matrix here. So remember when, some of this I am going to give you without a calculator, so let's practice our fractions here. Okay, 2/3 times 9, we put that 9 over 1. I like to reduce before I multiply, so the 3 and the 9 can both reduce. This will be a 3 and this will be a 1. So that's just going to give you 6 in the matrix there. You got 2/3 of 21. So 2/3 times 21. Reduce that. Divide both of those by 3, you get 7. So you get 14 for that one. 2/3 times -6. Reduce that. We'll get -4. And then 2/3 times 13. This is not reduced, right? So you'll just multiply straight across. You'll get 26 over 3. And you'll just have to leave it like that. Or decimal would be okay if you wanted that. But basically just distributing there. Okay, questions so far? Okay, sometimes you may be given sort of like these expressions like this. So I've I've been given these two matrices, A and B. Find each of the following. So A minus 2B means I would be taking A, which is 2, 1, negative 4, 3, 2, negative 2, and subtracting 2 times B. So I'm going to go ahead and multiply B by 2, so I'll have 0, 4, I'm going to multiply by 2, 2, negative 6, 6, and negative 4. And when I do that, that will give me 2, negative 3, negative 6, 9, negative 4, and 2. Leave there. Okay. On number 2, what are you going to have to do first? You could do that. You can multiply both of them by 3. I would add A and B first in this case because you can put those together. It is okay to distribute there and it will give you the same answer. But if you add those together first, you're going to have 3 times and then you'll get 2, 3, negative 3, 0, 5, and negative 4. So I just went ahead and added A and B together first, and then you can multiply. So you'll get 6, 9, negative 9, 0, 15, negative 12. Like that. And then if we do that last one there, if I do 2 times B, I'm going to get 0, 4, 2, negative 6, 6, negative 4, and then 3 times A, so I'll get 6, 3, negative 12, 9, 6, negative 6. And then you'll just subtract those two, so you get negative 6, 1, 10, negative 15, 0, and 2. There, I believe. Yes. Yes, there will be. Thank you. The most difficult thing for me, some of you with better accuracy than myself will not have this trouble. Most difficult thing for me is these problems. I mean, this is all simple arithmetic, but you have to do a bunch of it, and sometimes I mess it up when I'm doing it in my head. So be careful with those. In general, students usually do not want to do matrices on the calculator when we're just adding or subtracting because they are so simple to add and subtract. But the calculator does add and subtract matrices. So if you go to the matrix menu on the calculator, which again is the blue button and that X to the negative 1, and you go over to edit. So if for A, I would do a 3 by 2 matrix. And then you can just enter your data. Oh, good gracious, what did I do? Oh, yeah. Oh, I can't type in negatives, that's the problem. Calculator buttons. All right, so matrix A is in. If I go back to the matrix menu, go over to edit, I can go down here and enter 1 in B, 3 by 2. So 0, 2, 1, negative 3, 3, negative 2. So once those are in, now I could type in, if I go to the matrix menu, I could tell it A minus 2. Go back to the matrix menu, tell it B, and it'll give me that answer. As long as you type everything in right, you're less likely to make a mistake with that, but it's also takes you about as long to type it in as you could probably just do it in your head for a lot of these. We will, however, when we're multiplying. I'm going to make you multiply a few by hand, but we will use it for multiplying, because multiplying, not scalar multiplication, but multiplying two matrices together is much more extensive than adding and subtracting. All right, so now we do have here some equations. So these are a little bit different. We've got negative 7, 1, negative 14 equals x plus 3. So, whenever we look at this, x there is going to be a matrix itself. And if we wanted to, we could think of it like this. I'm going to call this x 1, 1, x 2, 1, and x 3, 1 for those elements. And so we can, to get that matrix right there, that x, by itself, we can do operations just like we would with regular equations, except for we'll be moving entire matrices, right? So we could subtract this matrix, which means we're subtracting that matrix that's 3, negative 1, 8. You can't read it. Over here, so for x, we would get, and for x 1, 1, we would get negative 7 minus 3, which would give us negative 10. We'd have 1 minus negative 1, which would give us 0 right here. Hold on. I'm sorry, 1 minus negative 1 is 2. Plus minus and negative would become positive, and then we'd have negative 14 minus negative 8. So that's like negative 14 plus 8, which would give us negative 6 there. All right, and if we wanted to solve any questions on 9, you also can kind of just like, depending negative 7, what number needs to go here? Negative 10. You can kind of just think about what number goes there as well. For 10, we could solve this like an equation, right? So we would subtract 0, negative 9, and negative 4. So 4c would be 20 minus 0 would just give us 20. Negative 1 minus negative 9 would be a positive 8. And 20 minus negative 4 would be a 24. And then we can't really You can't really divide matrices. You can only do scalar multiplication. But what would be the same as dividing by 4? If we want to multiply by 1/4. So we could multiply everything by 1/4 here, which is just dividing by 4. So that will give us 5, 2, and 6 for our final answer. Okay, any questions? All right, 11 and 12 are a little different because we're not looking for an entire matrix. We have these set up here. In fact, I wish we had one with a system of equations like we were doing this morning, but I don't think we do. Sometimes they make ones like that. So we've got the x and the y that we're looking for. So, excuse me, we can just make equations from what we're given. So, for example, I know this point plus this element has to give me 10, right? So I can make myself an equation where x plus 2 has to equal 10. So that tells me x must be 8. All right, and since x is 8, then I would know that an 8 goes right here as well. So to look for that y, I could do y plus x equals -5, and since I know that the x is 8, I could plug that in. So y plus 8 equals -5. Subtract that 8, so y equals -13. Okay. So this one, again, similar, x plus y is going to equal 16 here. Well, I could write that down, but I can't solve it because I don't, I have two variables in that equation. So I need to look at anywhere else the x might occur, which is right here. So I know that -4 plus 8 has to equal x. So that tells me x is 4. Then I can use that to answer this over here. 4 plus y equals 16, so y equals 12. For that. Okay, questions here? Okay, you may see something like this, 3x plus a equals b. We're supposed to solve for x. So in this case, you just need to plug those matrices in, and we'll solve like we did before. So we got 1, 0, -2, 3 equals -3, 4, 2, 1. And so we could subtract this matrix over here. 1, -2, 0, 3, which means 3a would equal -3 minus 1, so it's -4. 4 minus -2 is going to give me 6 right there. 2 minus 0 is 2, and then 1 minus 3 is -2. And then the last thing to do for this would be to multiply everything by 1/3, which is essentially just dividing by 3. So that's going to be -4/3, 2, 2/3, and -2/3. Now for us, we're doing really simple, small things here, but what this essentially is doing is solving 4 equations at one time, right? It's solving 3x plus 1 equals -3, 3x plus -2 equals 4, 3x plus 0 equals 2, and 3x plus 3 equals 1. So just imagine if you had an equation that you needed to know, and you had data for millions of people, right? You could, if your data was stored for millions of people, then you could solve this equation for all of them at once using matrices, which is going to be much, much quicker than, of course, doing each one individually.